Sorry, let's get you guys here. Good morning to all of you guys there at home. We got more people coming online. We got more people in the room. So good morning to you guys. The test we did yesterday, would have been graded, but my daughter was having a problem last night, so I had to tend to her, or yesterday. So anyway, I did grade another test, so I only got half the work done. So it's coming, but anyway, I hope it wasn't too difficult. There were over things we talked about, and philosophically, this is what I was mentioning to some folks earlier, is that, I do like to test people on things I lecture on. I don't test people on things I don't. That's kind of, as a math instructor, I think that's mean, if people do that, personally. So I don't, and I never have, and I never will, whether anybody likes it or not. I won't test people on things I don't go over. I think that's just not right. But anyway, we did go over some of those things, and what we have new is going to be somewhat important too. Everything we do is important. We have what's called inverse trig functions, right? So remember, we were looking at things, I think, this symbol, and this symbol that are in our calculator. I can't remember which one we used. I think we used inverse cosine. I think we used inverse sine. So in the last sections, just to kind of remark, these are the things that we used already. Okay? And the sad part is it's really bad because in math, I don't think you should use something you don't really technically know 100% about, right? But this is how this chapter was designed. So we did use those function keys in the calculator, but we now want to know what this is. Okay? Now, let me remark and recall something here, because this is an important detail. I guys want you to recall, what do you guys know about inverse functions? Because these are things you talk about in Math 125, intermediate algebra. These are things you talk about in pre-calculus. What do you guys know about that? What do you think? Anybody? What's an inverse function? It's kind of like a word. I don't think that's the best word to use for it, but it's the word that we use for it. Inverse. I would say to you, you know what the best word is? Substitute this phrase. If you really kind of want to know what that is, reverse functions. They work in reverse. Okay, now here's the idea, very, very simple. This is what I kind of express to those classes when I start talking about functions and even inverse functions. You think this is f, this is a function. You think of this thing as a what? As a machine, okay? You guys okay with that? And my favorite example is that of a juicer. So we're going to go back and kind of talk about the S portion here. This is like the S portion. Right? You may say, Mr. Judge, this is 241S. What's going on? Well, this is the S portion. It doesn't have to be at the end. It could be at the beginning or in the middle. I say you put it where it's most convenient. So here's the thing. X, this is a what? Is an input. Okay? Like, for example, what would you put in a juicer? An apple, a pear, what else? Beet. You ever have some beet juice? You guys get the picture? Right? I've had some beet juice in my life. So in a juicer, you drop in as an input value. Okay, I'll color that input. These are all inputs. You drop it in your machine, the function, okay? It's a juicer. What do you get as an output now? So you're going to get these things called Y, and these are all outputs. What do you guys get? Well, yeah, specifically, if you drop an apple, what will you get? Apple juice. Very simple, okay? If you drop a pear, what do you guys get? Pear juice. Very simple. And if you drop a beet, of course, you're going to get the what? The beet juice, okay? So I want to kind of make sure you guys are aware that this is really the concept of a function. And you might say, what is the relationship between y and f? Well, we always say y equals what? F of x. So x is the input, and f of x, also known as y, is the output, okay? So I want you to make sure you guys understand that. Input in what? Output. So this is the S portion of the course, so you guys know. Input and output. Easy breezy lemon squeezy. Okay, you guys know what I'm saying. So that's just a regular function. And so we actually studied, y is sine x. Y is cosine x. Okay? We've been working with these functions. In fact, there's 6. Y is tangent x, and so on. There's the others. But we've been doing things where you give me an x value, whether that's in radians or degrees. And then I give you a corresponding what? I apply sine, cosine, or tangent. Then I give you a corresponding y value. Okay? So we've been working with all of this. We've been working hard with all of this. All right, you guys okay with that? You go, wow, that's exactly what we've been doing. Every time we use a calculator, you use it with law of sines, law of cosines, right? Try to evaluate cosine of 45 degrees. You guys know that, unit circle stuff. So we've been actually working what I call forward and not backwards. We've even graphed these functions, okay? Because that's going to be important too. Now, this whole idea, and you say, well, what about this inverse function now, right? Because I have to introduce this to you guys. What about inverse functions? You say, what in the world are those? Well, I'd said, think of it as what? Reverse functions. Well, these are functions that work in reverse. And you say, what would work in reverse if I draw a picture? Okay. So I'm going to draw a picture here. You guys remember how this works? I'll call it G. I'll call it G. So how does it look like in reverse? Well, this time as an input, okay? Yes, it's an X value again. I'm going to put now apple juice. What do you think I'll get here as an output? If it works in reverse, also known as what? Inverse. So what do you think I'd get? I drop in my machine here, call it the what? Anti-juicer, or the reverse juicer, or the inverse juicer. What do I get if I put apple juice in there? An apple. Does that make some sense? It goes back in reverse. Apple. If I put pear juice in there, what do you think I'll get? Pear. If I put, for example, beet juice, what do you think I would get? A beet, because it's supposed to work how? In reverse. It's the anti-juicer. So all of these here are going to be green now. Apple juice, pear juice, beet juice. And all of these here is going to be orange. Apple, pear, and beet. Because these are the outputs. Now, notice what happened in terms of your colors alone. What just happened? They just what? They switched. You guys with me on that? So your inputs become outputs, and your outputs become what? Inputs. Okay? Wrong button. You guys okay with that? Maybe that was the right button. Inputs become outputs and outputs become inputs. And I'm going to say to you guys, that's what's going on. Inputs and outputs what? Switch. And there you go. So you're going to now have functions that look like this. We're going to start talking about these kind of functions. I want to make sure I write it in some order. Yeah. This way. Y equals now inverse cosine this way. Y equals inverse tangent. Okay. This way. So in other words, we're describing that inputs and outputs really switching. Okay. And that's the bottom line of where you get these functions. Now here, you can do it the same. They write it as y equals g of x, okay? But you really have other notation called inverse function notation. You may have a hint to it. Do you guys remember some of this in pre-calculus or in intermediate algebra? You guys remember? Okay, hopefully. You say, what's the notation? This is inverse function notation. Okay. So this is like the S portion of the course. You go, what is the S portion? Yeah. Inverse function notation. Inverse function notation. Okay, so you see that little -1 sign. So I just want you also to recall a very important fact here, okay? If you guys can recall, what kind of functions have inverses? Remember what you guys know from the past. What kind of functions have inverses? Do you guys remember? I mean, because there's more to the story, what we're looking at here. You're saying you just wrote down inverse sine. Well, yeah, I have to give you some details. You don't just have inverse sine in general. So it's related to my question. If you guys remember, what kind of functions have inverses? You guys recall? Well, yeah, what kind? Not every function will have an inverse or a reverse. Like in this case, just abstractly speaking, if we had a juicer, and the reverse juicer, right? Imagine pouring in apple juice and you get an apple instead. It's like, wow. Pour orange juice and you get an orange instead. Wow, that's working in reverse. Mathematically, we have those functions, but those functions will exist only for certain type of functions. Not every function has an inverse. That's what I'm getting at. Because it's an extremely important detail in our context here. We'll talk about it. I want to focus on that topic. Because I can't talk about inverse functions unless I talk about this aspect. So what do you guys remember and recall from your memories of inverse functions? Like, for example, what's the inverse of an exponential function? A logarithmic function. What's the inverse of a cubic function? A cube root function, okay? So there's functions that have inverses. And not everyone does, unless you do something very special, and that's what I'm getting at. See if you guys recall, clear out those cobwebs in a cold, early LA cold, which is not very cold, but it's cold, still cold. You know, people move to LA from the cold. That's all they care about. They don't even care about, LA's not special, except for the weather and getting to the beach and mountains on the same day. So what do you guys think? Anybody recall? There's a special situation that has to exist. Okay, so here's a special situation. F has to be 1 to what? 1. You guys remember that? Your function has to be 1 to 1. In fact, you have a graphical test. What's the graphical test to being 1 to 1? You guys know what it's called? Yep. The horizontal line test. So your function has to be what? 1 to 1, and it's the horizontal line test. What kind of functions have inverses? Ones that are 1 to 1 by the horizontal line test. So there's a lot of functions that fail, if you guys remember. Like x squared fails, right? Here's a classic failure. And by the way, I'm going to give you guys a formal definition for being 1 to 1. There's actually 2 definitions. We say f is 1 to 1 if, I'll do it in terms of letters A and B. If, when, I'll say when f of A equals f of B implies A equals B, okay? This is really the definition right in here of being a 1 to 1 function, okay? Now, this is an implication. This means that there's a guarantee. And if you say, what's the guarantee? Well, the guarantee is really saying the following. Same outputs, because it's the f of value, guarantee same inputs. Okay? So here's the deal. Same outputs guarantee same inputs. Okay, so here's the function that is not 1 to 1. So you guys know. And the graph of which, that's the parabola. So this is the S portion of the course. This is our definition. You say, well, why is this not 1 to 1? Well, here's what I want to say. It's very simple. See this picture? F of negative 1 is negative 1 squared, which is positive 1. F of 1 is positive 1 squared, which is positive 1. Okay, you guys with me on that? So you might say, what does this say? Well, f of negative 1 does equal f of 1 because they're both 1. Okay, so I have this situation, but what's the problem? Negative 1 is not 1. In other words, same outputs do not guarantee same inputs. Okay, because this was, again, the input values, if you guys remember that. These are different. And notice by the horizontal line test, even, you say it also fails the what? This is a horizontal line test. HLT. So it fails because it doesn't hit the curve in what? 2 spots. All right, you guys okay with that idea? This is the essence of it. So if you guys remember back in that course, if you guys recall, they'll say things like determine the inverse function for f of x equals x squared, and then they did what? X greater than or equal to 0. Okay. Do you guys remember that kind of question? Because it was a 4-step process. Anybody know what I'm talking about? It was a 4-step process. So, you might say, what was the process? Well, you know what they just did right in here? This is what I'm getting at. This is the big deal that I'm getting at. What did they just do? They what? They restricted the domain. Okay? They restricted your what? Domain. And that is what we're going to have to do here too. That's what I'm getting at. Now you might go, well, what do you mean they restricted the domain? Well, they defined this situation only for input values, right in here, these x values, right? They defined it only for positive values of x. What's the effect? And they included 0. So what's the effect, ladies and gentlemen? All the y values are right in here, by the way, the range. The effect is every input, if it's positive or even 0, will give you 1 output, not 2. And so it satisfies the definition because this doesn't even apply anymore. Okay? It passes the horizontal line test. It hits the curve exactly in one spot. Okay? So there was a process. And I'll go through the process. You don't have to do this process, but just for completion sake and the S in honor of S. You guys remember the first step? They say let y be f of x. So say y is x squared. Second step is the switching the domain and range. Switch x and y step. I'll write down what that is, and that's going to be x is what? Y squared, okay? Okay? This is the formal process of finding an inverse. Now, what was step 3? Remember step 3? Solve for y. I guess I'll put the steps. They'll say let y be f of x, just in honor of the supplement portion. And so when you solve, this is y is plus or minus square root of x. Remember, that means 2 things. One's positive, the other one is what? Negative, okay? And then the last step is you're done. You have the inverse step. But you got 2 solutions. Which one is it? Okay, you got 2 solutions. One is positive, the other is what? Negative. So the question is, which one is it? Now, go back to what this is, right? They're saying here, x is positive. Well, if I switch x and y, that means now y is what? Positive due to this step right in here. This is the switch step. Okay? So what that says is this is the inverse. That's the logic behind that solution. X is positive, switch x and y is positive. Okay? And you're done. Now you say, well, what is this? You say, the inverse function is the square root of x. So this is when I say to you guys that x squared and the square root of x, as long as the domain is restricted, they're inverses of one another. They work like the juicer and the anti-juicer. Okay, so that's kind of the setting I want to give you guys this morning as we warm up over our coffee. Because when you look at your book, you know what your book starts off with? I'm going to say, here's what your book starts off with. If a function is 1-to-1 with domain A and range B, then inverse function f inverse is a function with domain B and range A defined by. So this is what the book says. Wants to say to you, you have this kind of notation. Now, this symbol, so you guys know right here, this is like an equivalence symbol. This is, in geometry, it's the 3 lines. It means simply equivalent relationships. And this is what the book starts off this topic with. So the book doesn't give you Mr. Judge's S portion of the explanation of where this stuff comes from and why, everything we spent our morning on, because it is important, ladies and gentlemen, to, when you start a topic, that's important, you do want the foundational information. Do you guys agree with that? You do want to know the context of what you're talking about. I think that goes long. It goes further than just starting and saying, hey, guess what? F is a function that has domain A, range B. And then the inverse function, this is the formal symbols, does a reverse. This is my domain, range, domain, range. Okay, this is the formality of what the book is actually saying here. So we just have to find out what this means in our context. That's all, okay? So I just want to kind of let you guys know about that. So anyway, here's the deal. Here's what I always start with. What do we know about the sine curve, right? Here's a sine curve. And if I go to Desmos, if I can find it, okay, whatever. There we go. You guys know about that. Okay. And this one I'm just going to delete. What's the problem here with the sine curve? It's what? Exactly. It's not 1-to-1. So your sine curve in general is not 1-to-1. It fails a horizontal line test. You don't have an inverse sine in this situation because this is domain being all real numbers, okay? All real numbers in your domain. So you know what you have to do? What do you think we have to do to fix this? What we're going to do to fix this is, if I recall, you can do the following. Parentheses. 0 less than or equal to x less than or equal to 2 what? Pi. Okay, you guys okay with that? Now notice what I did. Even if I gave here, I'm going to do this here. Let's go back. Another equation. Y, I'm going to say just y equals 2. And I like to shade that one just for reference in orange. I'm going to dot it. Well, I don't have to dot it. Oh, I guess I did dot it. Okay. Here's what I'm saying. You guys see this horizontal line? Uh-oh. What did I do? I think I restricted my domain. What? Wrong. We're going to restrict our domain so it's 1-to-1. Because look at it. Is it 1-to-1 with this restriction? No, it hits what? 2 spaces, 2 spaces. So our restriction is going to be, ladies and gentlemen, right in here. Negative pi to positive pi. Okay? Now take a look. Now what do you guys see? Oh, what happened here? We got to restrict it. Is it 1-to-1? Say no. All right, not 1-to-1 yet. So we're going to restrict it even further. Divided by 2. Divided by 2. Okay, and then now what do you guys see? Finally, it's what? 1-to-1, okay? So I want to make sure you guys understand something here, okay? We really have to heavily restrict the domain so that this sine curve is 1-to-1 and has a what? Inverse. Okay, so take a look at that. Isn't it by the horizontal line test now? Okay. So when you see this, you know what you'll always see? They'll have a restricted domain. This is your restricted domain here. Okay? So they're going to always give this to you this way in every trig book. And you say, why? So that sine is what? 1 to 1 and has an inverse. So right in here. This is that restricted domain. Now, the range still of the function is between what? The function is still between -1 and +1 for the y value. So you still have, we color coordinate this orange earlier and then green for the range, the y values. Because you're still between -1 and +1, the amplitude. Remember that amplitude? So I want to kind of go back to this picture in Desmos. And there is a way. Let me see if I could do this. Where'd it go? There we go. No, I wanted to. Oh, whatever. Didn't I cut it? Oh, I'm going to try it again. Sorry. I'm having fun here. No, I don't want you, sir. Oh, come on. All right, whatever. There we go. Wanted to do that. It's important for us. All right, so here's our setting here. And this is kind of how we're starting to define everything now. Okay? And so now, here's what we want to look at. Okay? You say, what about the inverse function? All right, here's my definition. The inverse function to sine, because it's 1 to 1. over your restricted domain. Okay. I'm going to put this way. Over negative pi over 2, let's go to x, less than positive pi over 2. Okay. Becomes the following. There it is, all the way down in the corner. I'm going to say this. Inverse sine x is y. It's a function. And that's equivalent to, this is the if and only if. In the book. Sine y equals x. Okay, now the domain of this function in here, because this is what we're looking for. Not quite sure what color. I'll erase that one. This domain, we're switching domain and range. So x is now between positive 1 and negative 1, right? And now your range is between negative pi over 2 and positive pi over 2. You say, why? Because we switched domain and range. This here is the inverse function. Okay, but it is logically equivalent to this function over here. And I can even express where and why that comes from. Okay, because you say, Mr. Judge, what in the world, where do they get this? Well, go back again, and I want you guys to note the process I just went over, right? So if they say here, my function is sine, okay? And I just want to go over all the gory detail because it's important. Remember the first step, let y be f of x? So they say let sine be y. Remember the inverse process? Step 2, switch x and y. X is sine y. This is the switch step. Okay? And then you say, okay, what was step number 3? Solve for y? Well, you can't solve for y algebraically. So what they say is they wave their hands and say this must be the inverse function. Okay? And then step 4, they say let y be f inverse of x. So that's what the process is. It's right in here with step 2 and step number 3. It's just that I'm now coloring this new function here, or this relationship. Okay, oops, let me do this. This is what they're getting here. Y is inverse sine of x. This was the switch step. If I wanted to just be consistent with the process and the colors, that's exactly what's going on right here, ladies and gentlemen, right in there. And switching domain and range came in step 2 because you're switching x and y. So that's really the detail. Nobody in the world is going to give you, the book doesn't give you that detail. It just says, here it is. But this is, remember, the process for finding what? An inverse function back in those courses that you guys took, intermediate algebra and pre-calculus, just so you guys remember. This is all that. So the question now becomes here, since we have this here, right? This is what we'll be using right up in here. This is the what? This is sine curve with a restricted domain. But then the question becomes, how do we graph this? Because we can graph this. Do you guys remember the relationship between a function and its inverse graphically? Back in those courses too, there is a relationship. Anybody recall the relationship between any function and its inverse? Okay, you guys recall this. X and Y. You see this magical line right here? y is x. Any function and its inverse is reflected across that line, y is x. So you go, oh, okay, in Desmos, what does this mean in Desmos? Let me show you guys here. If I said now y equals, I wonder if it's going to restrict the domain automatically. There you go. And I'm going to put over here y equals x, okay? So I can demonstrate exactly what that is. Okay? What you're seeing is a relationship between the function and its inverse and the line y is x. Every point is reflected about that line. So if you look in the book, and you say, what does the book say about all of this? This is what the book says. And I'm going to get rid of you. Well, maybe I'll keep you. Okay. And what does the book say? Let's go back to Desmos. Notice this. This is very interesting to me personally. This is the curve of inverse sine, and it's in purple automatically too. This is the inverse sine curve. It too automatically restricted the domain in the way we did, because that's the standard way to restrict the domain. It doesn't have to have that restriction. It could be any restriction, but that goes way beyond our course. That's no longer elementary trigonometry. That's no longer trigonometry. You know, more calculus settings, but I'm going to copy this curve. Yeah. Do they all have a domain and range? Yeah, they all have slightly different. Yes. Add to existing note. Yeah, so they don't have the same domain and range, if I'm understanding the correct. Yeah, yeah. For the inverse functions, yes. So I'm going to put it right here. So the answer to that question is yes, and that's kind of what we have to look at for each one, in all honesty. We got to look at this information. So this, by the way, is this is a graph of inverse sine, okay? So I'll put that in purple, and we're looking at inverse sine as a function. But now you say, what is this? This is 1. This is -1. This is pi over 2. And this is what? Negative pi over 2. This portion has the address 0, 0. Okay, so every point on this curve has an x coordinate and a y coordinate. Down here is now the domain of the function, if I can get this. And then here's your range of the function. So here's the graph. Your domain is in orange. The range is in green. And this is the original sign that it came from, just so you guys know. Okay. And anyway. And what else here? Yeah, everything in purple is what I just said to you guys. This here is, let's typo. This is your new domain. And then this is your new range. We had to restrict the domain for sine to define this. And this is where it comes from. This is where you go back to. And you're going to see that. Okay, so you're going to see that. So this is all opening up the door for a few things. Okay, so here's what they're going to open up the door to you guys. They're going to say the following. Evaluate the following. Question 1. I'm going to go to your book. and say inverse sine of 1/2. Okay? Now, this is all without a calculator. All right, you guys okay with that? Now, you might say, how do we do this? Let me show you guys share with you guys the process. The standard process is let theta be inverse sine of 1/2. So that's how you start this. Okay, you guys okay with that? And then you might say, what do I do now? Well, you can go back to this definition. Okay? Let me get this here. I think I'm going to get some of this here. What are we saying now? This here is what? They're saying this is 1/2 and this is theta. You guys okay with that? What do we say it's equivalent to? Theta and 1/2. This is the definition. So what this now means is sine theta equals 1/2 by definition. So you go back over here. Now you answer the question, what is theta? Remember I told you these questions are specially chosen? I never said that, but just like the others, they're specially chosen. You go, what do you mean they're specially chosen? Go back to your right triangle, Pythagorean theorem. What's the definition of sine? Opposite over hypotenuse. What does that mean? The adjacent side has to be. This looks familiar. Yes. Remember I said to you guys, there's only 2 special triangles you have to memorize. It's like, oh my God. So isn't this what is this? Isn't this the square root of 3 down here? Pythagorean theorem. And in that case, what do we know? What is theta? Theta has to be what? Isn't that 30 degrees? Or pi over what? 6? Okay, is that, you guys know what I'm saying? I know my triangle looks ugly. Jeez. Theta is pi over 6. So what does this mean? This is what? Pi over 6. So this equals what? Pi over 6. Easy breezy, lemon squeezy. So you follow that process. You're following the definition. The definition here. And then you say, by the way, what if they wanted you to evaluate, they said inverse sine of now maybe negative 1/2. Just to kind of share with you guys that one. You go negative 1/2? Yes. What's the process? You guys remember? You say what? You let theta be what? Inverse sine of negative 1/2, and then what happens? You get sine theta equal to what? Negative 1/2. You guys remember this? So, what does that now mean? What's the difference between this question and the one we just did? There's a 1 major difference. Here we go. What is this? What is this symbol? Because it's going to be important for us in our future. What's that symbol? Reference angle. Isn't that a quadrant 1 angle? Reference? Okay, so always remember this. This is our reference what? Angle. So whenever you deal with the reference angle, it's quadrant 1. Sine is positive in quadrant 1. All students take calculus. Right? You guys good with that? And then you now say, hey, this is deja vu. 1, 2, square root of 3. You say, I know, Mr. Judge, the reference angle is what? What's my reference angle? Pi, it's 30 degrees or pi over 6. Just like we did prior. This is like the same thing, but they didn't give us a positive angle. They gave us a negative angle. All right, you guys okay with that? Now, let's be careful here. We have to answer this question here. What is theta? So I'm going to go to my curve here, my original curve. I'm going to get rid of this. Don't need it. And don't need it. And I'm going to go to the original right up in here. I want you guys to notice an important detail for this sine curve. Oh my God. This is a detail that people overlook. This is sine, okay? Now, you know what this is right in here? Let me go back and color this. You know what this portion here is, actually? This portion, and then how about this portion here? Okay? This is like from 0 to what? Pi over 2. Isn't pi over 2 90 degrees? That's what I'm saying. 0 to 90 degrees. What quadrant is this? This is quadrant 1. You say, I know. But then what about this quadrant? This is negative 90 degrees. Sorry, I didn't give the whole. That's not negative 90 degrees. Oh. Whatever happened there? Don't know. Okay. This is what? Negative 90 degrees. Which quadrant are you referring to now? Outstanding, right? That's quadrant what? 4. You see, when you restricted the domain here, I'm going to shrink that now. When you restricted that domain, what did you really do? Okay? All students what? Take calculus. Remember this? I know it's a lot of detail, but it's worth knowing. So inverse sine is good only for what? What colors are that? My reference and for quadrant what? 4. Restricting the domain through quadrants 2 and 3 out. So you only have quadrants 1 and quadrants 4 defined. You with me on that? But it's negative angles for quadrant 4. Okay? So the moral of the story is this. Inverse sine, if you go back and you said, inverse sine is good for what? -1 to +1. Is that true? I have to give an answer for theta. What do you think theta is going to be? It has to be negative what? pi over 6. I'm looking at the wrong one. So theta is, and this is what you guys want to know, negative pi over what? 6. Okay? Theta is negative pi over 6. So this angle here has to be what? Negative pi over 6. And that's the difference. So negative pi over what? 6. You say, why? Because of that picture we've been looking at. So remember, if this here, this is your reference angle. Theta is positive here, and then you have to rotate in the other direction. Okay? You're rotating in that direction, and theta is negative. So this is why theta is a negative pi over 6, because you threw out quadrants, what, to these other quadrants. So you have all students take calculus. What that means here is sine is positive, and here sine is what? Negative. So the negative angles are going to be associated with the inverse sine function, is what I'm saying. When you use inverse sine, you have negative angles. Because the positive angles don't work. Look at the domain of the restricted function. You can't go out to quadrants 2 or 3. They're thrown out. You only have quadrant 1, and you only have quadrant 4. And that's good. Yes? So if it's negative, it's going to be quadrant 4, but we use quadrant 1 to find out. Yeah. Your reference is always quadrant 1. Absolutely. Mm-hmm. You always go back to find the reference of the quadrant 1 angle. But this is where it changes on you when you're dealing with inverse sine. You don't use positive angles. Okay? Easy breezy, lemon squeezy? Should I have you guys try 1 or 2? Or how about this? We could try it together. They want us to evaluate now what? Inverse sine of, how about this? Negative square root of 3 over 2. These are like kind of the hard ones, I would say. Okay, so start the process. And you say what? You're going to let theta be what? Inverse sine negative square root of 3 over 2. And if you do that, that means sine theta is negative square root of 3 over 2. So if sine's negative, it's a quadrant 4 angle. Just to let you guys know. Theta is negative. Theta is in quadrant 4. Just to kind of notate that. Sine's negative. It's only in quadrant 4 for inverse sine purposes. All right, you guys okay with that one? So that means you're dealing now with the what? Reference picture, right? Okay, you guys okay with that one? So the good news, like I've been saying all along, you know one special triangle. Square root of 3 over 2. Which one's this going to be? This is what? 1, is that true? You know, we only know 2 special triangles. That means this is 1, this is 2. What is that reference angle going to be? This is 60 degrees. It's pi over 3. Is that true? You guys okay with that? But this is not a quadrant 1 angle. This is a quadrant 4 angle. So what's the answer going to be now? Yeah. Negative what? Pi over 3. That's it. All right, you guys see what I'm saying? Easy breezy, lemon squeezy. And no, it's thinking of it backwards, but it's not. You say, how am I answering these questions? I'm thinking backwards. No, you're actually thinking forward. Because remember, it always comes down to what? To that. It's cosine or sine or tangent of an angle. And where does that angle live? That's the exercise. And you see this in all throughout this chapter, those two special triangles. Anyway, let's do another one. You want to do an easy one? How about this? What if they give you inverse sine of 0? What would you say that is, right? Again, you say what? Let theta be inverse sine of 0. What's the definition? Sine theta equals 0. Oh, where does that happen? What does theta have to be? I don't even have to draw a triangle here, do I? Do you guys have to draw a triangle? Where is sine theta 0? Go back to the sine curve. That's inverse sine. Where is sine 0? Do you guys know? Right there. That's the coordinates 0, 0. This is theta. This is sine theta. Okay? You guys see what I'm saying? You get to go back there. You say, well, when does that happen? Well, it happens when theta is what? 0. So notice, I'm not even doing what? That 0. I'm not using a calculator. So you want to kind of know and understand the logic of where it comes from. That's the idea. Because if you can do that, then you go on to the next section and you can do a lot more. How about this one? Right? Inverse sine of 1. Go through the same process. You let theta be inverse sine 1. By definition, it means sine theta equals 1. And you say, what does theta have to be, right? What do you guys think theta would be? When is sine 1 pi over 2? That's it. Maybe you just have to go back to the sine curve. You go, what sine curve? Right over here. Right? You're talking about this point. That happens when theta, what's 90 degrees again? Pi over 2. And this is where 1 would be. Okay, easy breezy, lemon squeezy. All right, and they give you the following now, right? So we're going over these kind of ideas. Inverse sine of -1. Okay, compare and contrast. You're going to go through the same process. You let theta be what? Inverse sine of -1, which means sine theta equals what? -1. What do you think theta is going to be? When is sine theta -1, ladies and gentlemen? It's negative what? Pi over 2. So if you don't believe me, we go back to the what? Sine curve. This is where we're looking at. Negative 90 degrees is negative pi over 2. And then this is where it's -1 here. Okay, we're looking at this angle. We're looking at this y value, -1 now. This is really the location. Like the prior one was up here. Okay, so for inverse sine, you have negative angles. We restricted the domain so that sine could be 1 to 1, so it even has an inverse. Without it, we can't even have the conversation of being, what is an inverse sine? And it's also known as arc sine, by the way. Okay, and I'll give you guys a fact from, if you guys remember some of these facts from inverse functions, okay? You look at, and generally speaking, you have what's called composition of functions. F of F inverse equals F inverse of F, and they equal X. This is in general. This is with any function and its inverse. Okay, so in this section, you might see, okay, you have this thing, sine of, inverse sine of x equals x. You also have inverse sine of sine x equals x. Okay, so you're really using the general relationship between a function and its inverse here with composition of functions. This is back from Math 125 and pre-calculus. Now, when you take this class, you see this, but I'm going to remark about something right in here for you guys. This has to be defined. So what I'm going to say to you guys, pay attention to this x. This is only good for what? What's the domain? Okay? This is what I'm saying. That domain, I guess I'll leave it gray maybe. You have to have the inverse sign exist in terms of a value in order to use it. And that means now your x has to be between these numbers. So in your book, you might say, how come I have that relationship? Well, because it's the relationship between a function and its inverse in general. Over here, and I think I have it backwards, I apologize. That's negative 1 to 1. Okay? So this is why your book will say, hey, define x between negative 1 and 1, and then it all makes sense. Here, for it to make sense, is you restricted the domain for sine, the inside function. Here, sine has to be, between these. Okay? So these formulas are in your book. If you said, I'm going to read the book and I'm going to take a look at that, where do these formulas come from? They come from this in general statement about functions and their inverses, but these things have to be defined, is what I'm saying, in order to use it. It comes from this. If you guys remember that, 125 or 260. Okay? All right, now I know we have a few minutes, but the question is now going to be, what about cosine? And how do we handle cosine? Well, we handle cosine the same way. Okay? You now have the cosine curve, but you have to do what? If you looked at cosine now, you have to restrict the cosine's domain as well. Okay? Now, cosine's domain is restricted differently. 0 to pi. Okay, we're going to call that the what? Restricted domain. Does anybody remember why we have to restrict that domain again? To make cosine what? 1 to 1 and have it have an inverse. So if I go to Desmos and we say, what do we do now here? Well, here's cosine. Y equals cosine. This very much is not what? This is not 1 to 1. It doesn't pass the horizontal line test, right? So you restrict your domain. You say, how do we restrict it? The way I gave you. That's formally how we restrict it. 0 less than or equal to x, less than or equal to 2 what? Pi. And actually, it's I think I did, it's pi. Okay. There we go. So what do you guys think now? Is that a nice one-to-one function now? Okay. So I'm going to put this here. Let's play with this. Because you don't know, I may use these videos one day to become a billionaire. What do you guys think? Anyone buy math videos? Okay. Your range still is going to be what? Between -1 and what? +1. So restricted domain. Right in here. Notice your range still is between -1 and +1. All right, you guys okay with that? So it's 1-to-1. We can invert it. And you go, well, how do you invert it? Well, here's going to be your definition of that inverse function again. In every book, you have the following. Okay. Y equals inverse cosine of x. That is equivalent to saying cosine y equals x. This is what you always go back to. This is that blue. Get back to that. Okay? This is the definition of the inverse cosine. And you say, well, what happens to the domain and range? Well, they switch. -1 less than or equal to x, and then y is going to be between 0 and pi. So they switch. So I just want to color coordinate this. Orange. Green, because you're talking about the inverse cosine. This is inverse cosine. And then you say, well, what does that graph look like? Well, you guys know something. You have y equals inverse cosine x. And again, I'm going to use this here. And again, I'm going to change this to maybe green, I guess. Yes. There's green. Yeah, my eyes are doing tricks on me. Okay, reflected about the line y is x, so you guys know. Be careful. I'm going to get rid of this. So here's my inverse cosine curve. Okay? And we'll just bring this into Desmos. Yeah, we're going to talk about what quadrants it's in now. It's a different situation. Come on. Okay, so if you went back here, let's talk about our quadrants. Right? How do we restrict the domain? This is really from 0 to pi, which is 180. This is going to be, what quadrant is this? What was the other color we used? Don't remember. This is quadrant what? Quadrant 1. And what is this quadrant over here? This is quadrant what? 2. So we're keeping quadrant 1, and we're keeping quadrant 2 now. Is that right? Because all students take calculus. I won't write that down. I got a spam call coming in. Okay. But this is how we define it, so you guys are aware. But yes, we're going to keep quadrant what? If we said, what's going on with cosine? 1, 2, 3, and 4. All students take calculus. We just threw out what? These two quadrants. Notice this is cosine. So cosine is positive in quadrant 1, and cosine is negative in quadrant 2. There are no negative angles for theta here, okay? They're all positive angles. Theta is going to be between 0 and what? Pi. Okay, you guys okay with that? So I just want you to remark that theta is always positive. Cosine theta could be negative, but theta is going to be positive. That's different than the sine and inverse sine. I just want to kind of remark about that. And, you know, we could continue. I think we're out of time, though. But just wanted to share with you guys these inverse functions that exist and how we use them. And that's going to be the next phase. Okay, what do you guys think? Is that okay? Well, come back. We'll work more with the inverse cosine. And then we're going to also do inverse tangent. And then that's that, you know. So I want you guys to be aware of these things because they are useful. So we'll see you guys tomorrow. Take care. Stay safe. Have a wonderful day. All right, good morning to all of you guys. Good morning at home where it's nice and warm. Boy, it was tough getting up for me this morning. I don't know how it was for you guys. I'm still not awake, trying to drink my coffee. I'm like, oh my God, I'm really out of it. Couldn't even get to sleep for some reason. Odd. Anyway, I think I'm thinking of way too many things. So, let's get started on this amazing topic called inverse trig functions. Remember, it really should be called reverse. Is that right? It should work in reverse. And what you guys are actually seeing here is where we left off. This here, I would say to you, if I can get my there we go, Apple Pencil to wake up even. I guess I'm not the only one asleep. Okay, so you guys have this here, right? There we go. So this is like the definition, and come on, pencil. And how we've been using this is we're calling this theta, right? We're calling this thing theta, really, because it's an angle, right? It's an angle theta. So why is an angle theta right in there? We're just switching inputs and outputs, and you get another function that has a graph with a restricted domain from -1 to 1. So remember, this domain here, gosh, what is that? Do I have to? Seems like this pencil just, oh, that's what it is. We got to check. No wonder it's not doing anything. So we're going to look at this for a few seconds here. It's like, no wonder. Yeah, no, this, you got your notes. Don't worry about it. Thank you so much, though. I mean, it's, technology is, I don't know, what do we say? I don't know about you guys. It's so annoying to me. Technology is, I get to talk like an old man I waste some time while my pencil charges. When you live this long, you earn that right to complain. I know you guys don't listen to it because I never listened to my dad when he complained, really, but he was always complaining. Yeah, technology is interesting. It's great, but yet, annoying. I think they want to make everything, I don't know. Yeah, it's kind of an interesting thing. I got to figure out how the pencil even works, how to disable all those, when you touch the pencil, how to disable everything. Yeah, in the settings? Oh, let's take a look. In the settings here, I would say, let's go back to this so you guys don't see all my files. So in the settings in the iPad, right? Yeah, so let's go to settings and let's look for.
It's lower on the center top now. You got over it. Go back on the center right now.
Oh, there we go. Yeah, you're right. And then we do what? Switch between current tool and eraser? No. Turn it off. Just turn it off. Nice. Jeez, it's so annoying. Anyway, let's see what happens here. So what I wanted to mention to you guys really is the domain. Remember, this is a restricted domain. It's from -1 to 1. That's like the angle. And then you have the range. Okay, it's right from 0 to pi. So the point I'm making is the inverse function, as you guys are seeing here, is a function itself. And we study this function, we look at it as a function with a restricted domain. That's all I was trying to say. Okay? And your input now is the orange part. The output now is this part. And then I had it different colors because we switched. So I was emphasizing the switching domain and range. But looking at this as a function itself, here's my input, and then here's the output, right? Domain and range, restricted domain. And I guess you can say, although we don't talk about a restricted range, but that's really what's going on. It's not all real numbers, okay? So this is a function. It's a nice one-to-one function, you know? So anyway, that's the curve. And now we just have to use it. Now you say, what do you mean use it? Remember, these are all specially chosen. They're going to say to evaluate the following, right? So we're going to look at some examples. They want us to evaluate inverse cosine. I'm going to put -1/2, okay? I don't know if I started with that one last time. Maybe I should start with a +1/2 just to wake up. And so, you know, we're going to have to evaluate this. So remember, the process is exactly the same. You let theta be what? Inverse cosine of 1/2. And so by definition, again, you can say by def, cosine theta is +1/2. Okay? Now, I want to make a big deal about this here. Okay? Here's the big deal. This is positive. Now, what that means is that theta is in quadrant 1. Okay? Because cosine is what? Is positive. Let's make a very big deal about this. Okay? Because this is the idea. So you say, why is it such a big deal? Because remember, all students take calculus. And when we restricted the domain, we threw out quadrant 3 and quadrant 4. Okay? So in other words, quadrant 1 is that reference quadrant. That's pretty much what they're talking about because cosine is positive in quadrant 1. Now, what do you guys know about quadrant 2? Cosine's negative. So if cosine were negative, it would be a quadrant 2 angle. And that's the logic behind it, okay? Cosine's positive, quadrant 1. Cosine's negative, quadrant 2. So the next thing we have to look at, again, remember this. This is theta. The definition of cosine now is going to be what? Adjacent over hypotenuse. And again, notice that this is a special what? Triangle. 1, 2. Okay? So theta is going to be 60 degrees, or theta is pi over 3. All right? Because that's a 60, 60, 60 special triangle. So, like I said, this is special triangles. Only 2 of them. Only 2 special triangles. So this is the answer. And so we just say, I know this equals what? Pi over 3. So there it is, ladies and gentlemen. That's how you answer this particular question. Yeah, because if you notice the domain or the range here, right? Notice this. The question is, should we give our answer in radians, right? The answer is yes, because you go from 0 to what? Pi. And that's in radian measure, you know. And really, you do want to use radian measure, remember, is another way of saying real number. That's all it is, a real number value. Like a real number on the real number line. So pi is about 3.14, right? So if you look at the graph, notice this. This endpoint here is supposed to be where pi is, 3.14 approximately. Okay, so it's like on the y-axis, it's a real number. So that's a good question because, you know, I don't think sometimes people realize that detail, but it is. It's there. And if you start talking about further math with this, like in calculus, it has to be a real number, you know, a radian measure. But radians is another way of just saying what? Real number. Just think of it that way. You go, oh my God, radians are so scary, that word, right? You go, oh my God. No, just think of it, real number. Any number on the real number line. So I'm going to give you guys another example. I want you guys to note this here. Here's a note. They can give you a very similar question to evaluate, right? just to compare and contrast. So again, you always start by, this is kind of what I do, and I know because you're using the definition. Let theta be inverse cosine of negative 1/2. And then by definition, you have cosine theta being negative 1/2. Okay. Now, the second you say, wait a minute, this angle is what? Cosine theta is negative. That means theta is in quadrant what? 2. Okay. Theta is a quadrant 2 angle. Because you went back over here, all students take calculus, and we said, oh yeah, we threw out quadrants 3 and 4. They don't exist for inverse functions. Only 1 and 2. And in quadrant 2, cosine's negative. So sure enough, it's consistent. But remember, what did you just find here? Remember how you would do this. If you didn't do the last question, you would always go to the reference angle, the positive cosine. Always, always, always. And what you'd always do is create that right triangle and then determine what special triangle that is. Okay? So you go, oh, here it is. Definition of cosine is adjacent, hypotenuse. Oh, yeah, this is again the what? 30, 60, 90 situation. That's the square root of 3. So yeah, theta is 60 degrees or pi over 3. Now this is the quadrant 1. This is the reference angle, okay? So notice that symbol here. This is a reference angle. A reference angle. This is an important detail. Extremely important detail. Pi over 3. Okay? So you might go back and say, well, how does that work? Well, remember the reference angle if I said this to you guys here? How does it really work? This here is that reference angle of pi over 3. Okay? That's not the answer, though. You say, well, what's the answer? The answer is this angle over here. Come on. Okay. This is the theta, right? It's a quadrant 2 angle. So how do we get that? Isn't that pi minus the reference? So for quadrant 2, it's pi minus the reference. Here we go. It is pi minus the reference of pi over what? 3. And then at this point, what do you guys do? 3 over 3. Which means we have 2 pi over what? 3. This here, ladies and gentlemen, is your answer. This is what theta is. This is what we're looking for. Okay? So that's how you would use that. And you say, oh, does this equal, 2 pi over 3? And the answer is yes. And that's a quadrant 2 angle. That's between 0 and pi, by the way. 3 pi over 3 is pi. So this is the exact what? Process. Notice how similar it is to finding inverse sine. Okay? And, for example, they can say, can you give me inverse cosine of 0 here? Right? I'm not saying these are the trivial questions, but in some ways they are. Remember, you do the same process. And then again, this is by definition. You say by definition, what is this? This is cosine of theta being what? 0. Okay? Now, this one doesn't take a lot of thought. It shouldn't. Why? What do you guys know about theta? Where's cosine 0? Pi over 2, 90 degrees. Go back to the curve. It's an intercept. Is that true? So this one is pretty nice and simple. It doesn't have to, you don't go to a special triangle. you think of the curve, the cosine curve, because it's an intercept. Remember how I asked you guys to tell me the x-intercepts on the test? That's one of the reasons, because these little details we want to know about. So like personally, like when I see some of these questions, like in science courses, you'll see it, you go, oh my God, it happens when theta is pi over 2. This is kind of like in my experience, important kind of questions. And then similarly, if we say, what about inverse cosine of 1? Same process. You let what? Theta be inverse cosine now of 1, and then by definition, it means cosine theta is 1. Now, you again, think of the curve. Think of the curve. What is theta going to be? Theta is 0. Is that true? Okay? Because that's where you have the maximum value. You go, really? Yeah, all I'm doing, ladies and gentlemen, is going to the cosine curve. And you really should be thinking of the restricted domain. Here's what I mean by that. See this here? First question was right in here. This is pi over 2. Okay, the second question is right in here. This is theta being 0. This is your theta that we're talking about for cosine. And of course, they can even ask you what? Where is it -1? And you're going to say, I know, that's where it's what? Pi. This is what I mean, going back to that cosine curve. So the graphing portion, really, it's not a learn and forget situation, right? It's not like you say, hey, I learned that on the first test. I don't have to remember what a cosine curve looks like at the end of the course kind of thing. That's not how it works. That's the issue with, well, I shouldn't say it's the issue with math. That's true for a lot of disciplines. Doesn't matter what it is. Okay, whether it's a history discipline or social science or psychology, sometimes what you learn in the beginning is something that you see all throughout the course, and even the next course, like these definitions and stuff. So this is no different. So you go, oh, okay, we're answering some of those, what we say, trivial-ish kind of questions, and they're not trivial, but they do ask you these questions. I'm saying trivial in the sense that you do not create a special triangle, right? What you do is you look at the curve instead. So this becomes cosine theta being what? -1, and that's when we said theta was pi. Okay? And that's the last example that we looked at, just to kind of notate this. Okay? Just to notate it. Because those are like questions they ask. They ask those kind of questions. Now, I'm going to do a little bit of jumping ahead here, okay? And I'm going to say to you guys, by the way, you may have a question that looks like this. Inverse cosine of maybe -0.9. Right? What did we just transition to, by the way? Do you guys know? Yeah, what do you think we just transitioned? What is this? We have to evaluate that? The answer is yes. So you're going to let theta be inverse cosine of what? -0.9. Is that true? And then that means that cosine theta equals what? -0.9. About this. Jesus. All these emails. Okay, and then you say, okay, Mr. Judge, I know what this means. You warned me about something like this. What does that mean? Theta is in quadrant what? 2, because this is a negative value. Is that right? You guys know what I'm saying? And then you go, oh my God, okay, so what does that mean? It means I got to go to the reference, reference information where it's positive. Okay? And then you say, Mr. Judge, what do I do now? There is no what? Special triangle here. Remember I said all of this is very specially chosen so that there's a special triangle? And there's only 2. So, you know what they're going to say for this kind of question? Here's what they're going to say. These are going to be your instructions. They're going to say, use your what? Calculator to determine, inverse cosine of 0.9. So for that set of questions, all they're trying to do is get you guys ready to learn how to use your what? Calculator. And I think that was negative, right? All right, you guys with me on that? So this is going to be now your instructions here, and it's good. You should be able to use a calculator as well. Okay, they're very useful because when you start dealing with a lot of the applications, sticking with special triangles is thrown out the window because not everything actually has a special triangle format, or the geometry isn't by a special triangle. So just to kind of let you guys know, okay, and you say, well, where is that? You see that blue key above cosine? At least on my calculator, right? So what you would do, and remember, what mode am I in? So you guys know, if I find the mode, I can't even see that, but I'm in degree mode. Okay? Okay. So I hit second inverse cosine. Now at the bottom, don't use the subtraction key. If you do, you'll get an error. This is negative 0.9, and close that, okay? So in this TI, and I like the TIs, but whatever. Okay, there we are. Now, what do you get? Okay, you see what you're looking at here? You might say, what am I really looking at? Well, go back up here that we said. Right? We're going to erase all of this because it doesn't really apply. They want us to use a calculator. The only way you could do it is with a calculator. This is what you just found here. It was theta. Okay? Now, what is theta going to be here? What does it say? 100. Let's go to the nearest whole number. You guys okay with that? Let's keep our life simple. This is 154 degrees. So theta is 154 degrees, ladies and gentlemen. All right, that's where you guys go. That's what you just found. So I just kind of want to mention this is where it comes from. So you still have to be able to use your calculator. Notice that is still a quadrant 2 angle. And you guys probably already know how to do that anyway. But, in case you don't, you get to get extra practice on this. Good stuff. Easy breezy, lemon squeezy. All right, now let's do something like this here for us. I'm trying to go back here. All right, let's go back now, and then you can say this. We already talked about that, using your calculators for these. So there's a whole set of questions using calculators. I'm going to say, what about our tangent curve? Okay. Now, generally speaking, in Desmos, we're going to get rid of all of this. Generally speaking, here's tangent. Okay, tangent is also periodic. It's a periodic function. What does periodic mean? has a repeat pattern forever. So then you might say, well, what does this even really mean? We're going to have to restrict our domain. Remember when you guys drew one cycle of tangent? Right? Something simple like this. You say, oh, y is tangent x. What was that domain? Do you guys remember? Yeah, negative pi over 2, and that's strictly less than. Okay? Because at pi over 2 and negative pi over 2, tangent's not defined. So remember, this is a restricted domain. So I'll color this thing orange like I do. Orange is our domain, I guess. Now, what's the range, though? You guys know what the range is when you look at this? Because I'm going to restrict this domain here. Let me do that here. Where do we go? No, not functions. We go over here. You guys see this here? I'm going to do this. X equals pi divided by 2. X equals negative pi divided by 2. Okay? So you look at these kind of details, right? I'm going to try to do what I did yesterday. Oh, here we go, right? Sorry. All right. Maybe a little better. What's your range? Do you guys know? Because we're talking about the domain, input values being here and here. Has vertical asymptotes at pi over 2 and minus pi over 2. So what is the range? You guys remember? Yeah, what you'll see is this. They'll put negative infinity less than y less than positive infinity. Okay? Do you guys know what that's really code for? Yeah, that's all they're saying is this is all real numbers. Any real number is the range. That's all they're saying. Okay, so just kind of want to share with you guys how we get that, because remember, we're really talking about an x coordinate and a y coordinate, right? And the x coordinate is here, the y coordinate is here, so you're getting, information about tangent. Now, more importantly, tangent under this scenario is what? Do you guys remember this? What is this? By the horizontal line test. What do you guys know about tangent? It's 1 to 1. If it's 1 to 1, what does it mean? It has a what? Inverse. Yes. Switch domain and range. And so now I'll give you the definition here, right? Like your book does. Your book's going to say y equals inverse tangent of x, switching domain and range, is equivalent to saying tangent y equals x. That's the same exact statement. Okay, now if you switch your domain and range, now your x value is what? All real numbers, because that's switched. And the y values right up in here, I'm looking at domain and range. We're switching these things. So you say, okay, then my range is from negative pi over 2, or yeah, here's my. Okay, you guys okay with that? So remember, this is what I'm going to do now. I'm going to think of this inverse tangent as a function of x now. You say, Mr. Judge, you got your colors wrong again. No, I don't. Because this is an input. This is an output. We're looking at the Cartesian coordinate version now. So I just switched my domain and range. So you're saying that for the inverse tangent, you can have all real numbers for a domain input? Yeah. Output is going to be between negative pi over 2, positive pi over 2. Now, remember what I shared with you guys last time as well, right? What did I say about functions and their inverses? Bless you. They're reflected about the line y is x. Is that right? So if I go now here in decimals and say, what is the inverse tangent function? Come on. What do you guys see in green here? You should see exactly that reflection. Okay, now I'm going to get rid of my line here. I'm going to get rid of tangent. I'm going to get rid of this line, and then I'm going to emphasize another few things about this. So if you guys take a closer look, okay? This is your inverse tangent curve. However, now we have y equals pi divided by 2, and you have y equals minus what? Pi divided by 2. Okay? Colors here. Let's fix this. Okay, you see this here? You now have, we call this horizontal asymptotes. So you get horizontal asymptotes, not vertical anymore. Okay, let me see, between 1 and 2. Yeah. Yeah, maybe right here, I guess. Yeah, you got to do it slowly. There we go. Okay, and notice what? Well, I don't know. What do we want to notice? Can I ask you guys this? If y is theta, right? Don't we usually call that theta when we start to use this? What quadrants are we really talking about? Right? Go back. See this here? This isn't even a full quadrant. But this is quadrant 1, and then this is quadrant. These are negative angles again, quadrant 4. This is just like what? The original one we started with. Quadrant 1 and quadrant 4. So when you start to answer some questions again, you got to go back to the all students take calculus. Negative angles? No, let's take a look, right? Let's take a look. Isn't this quadrant what? 1, 2, 3, and what? 4. Okay? So when they say theta or y is between what? 90 degrees and what? Negative 90 degrees. Okay? This is quadrant 1, and then negative angles are quadrant 4. All students take calculus. So you actually threw out quadrant 2 and quadrant 3. So here, tangent is positive, and over here, tangent is what? Negative. So this is very similar to inverse what? Sine is what my point is. Okay, now you say, what are you talking about? Let's look at some examples, right? They're going to tell us to do what? To evaluate. So maybe they tell us evaluate now inverse tangent square root of 3. What's your process? You let theta be what? Inverse tangent square root of 3. Is that right? Then what does that mean about tangent theta then? So tangent theta becomes what? Square root of 3. Easy breezy lemon squeezy. And what do you know? Since tangent again is what? Positive. What is theta? Theta is in quadrant what? Quadrant 1. That's your reference quadrant. So you don't have to create the reference angle. Okay. What's the definition here? So you say, is that square root of 3 over 1? It is. So what's the definition of tangent? Opposite over adjacent. What does that mean about my hypotenuse? Right? Isn't that 1 squared plus the square root of 3 squared, which is 1 plus 3? It's actually square root, right? Oh, this is 2. And you say, Mr. Judge, I've seen this special triangle all throughout the course. What is theta? Right? You guys know what I'm talking about? Isn't that 60 degrees? Pi over 3. Okay, you guys okay with that one? So you answer the question. This is going to equal what? Pi over what? 3, ladies and gentlemen. There it is. So that's what you're looking for. Theta is pi over 3. And if you said, what if they gave me this? Let's know, right? Compare and contrast. What if they gave me negative square root of 3 instead? Okay, how does this all work with the all students take calculus and that you only have quadrants 1 and quadrants 4? Okay, the process is exactly the same. You say, let theta be what? Inverse tangent negative square root of 3 Tangent theta is what? Negative square root of 3. And you go, wait a minute. Tangent's negative? Yeah, what does that mean about theta? Theta is in quadrant what? 4. Easy breezy lemon squeezy. All right, you guys okay with that? So you might say, well, what happens now? In theory, you go out to the reference angle. So you go out to the positive angle now, right? Go out and do that work again, just so you guys can see all the gory detail. Quadrant 1 angle, definition. And then you go, oh, I know what this is. This is 60 degrees, which is pi over what? 3. Okay, you guys notice the work? If it's negative. So then what does that mean in the grand scheme of things if all students take calculus? Well, what's the deal? It's a quadrant 4 angle. You just found the reference angle to be what? This is the reference angle. Pi over 3. Okay? So how do you answer this question here? This is going to be different. What is allowed? See this here? What's allowed is negative angles. When you rotate clockwise, theta is negative. Okay? So negative angles are allowed. You say, how do I know? We're looking at it right in here. That's how we know. Theta could be negative. So, what this means, ladies and gentlemen, final answer to this question. Let me find the question. Oh, here we go. This means that this answer is going to be what? Negative pi over what? 3. Okay? Negative angles are allowed for inverse sine and inverse tangent, but not cosine. I'll say it again. Negative angles are allowed for what? Inverse sine and inverse tangent, but not cosine. Positive angles for cosine. That's it. All right, you guys okay with that? Easy breezy lemon squeezy? Okay, one of the ones that you have to know here, this happens a lot. You guys see this example here? If we look at this, you guys okay with this here? What about inverse tangent is 1? We say let theta be what? Inverse tangent of 1, that now means tangent theta equals 1, okay? And you go, oh, that's nice and positive. What is theta in? Theta's in quadrant what? 1. Okay, you guys okay with that? You say, how do we know? Because tangent is what again? This is what? Positive. So you say, well, how do we handle that? Well, create this special triangle here, I guess. Maybe. Yeah, this shows up a lot. You see this here? Opposite over adjacent. Isn't this the square root of 2? Do you guys know what theta has to be then? What is theta? 45 degrees, pi over 4. Absolutely. So this one is nice. Theta is pi over 4. Say here, you're pi over 4 here, you're pi over 4 here, and there you guys go, okay? That's what theta is. Easy breezy, lemon squeezy. I just want to note what happens when they say inverse tangent is negative. Follow the process. Let theta be inverse tangent of -1. It means tangent theta is what? -1. And then you go, wait a minute. That number is what again? Is negative. What's going on here? All right, what's going on with this business? Tangent's negative. Okay. We got to go to the reference. Because theta is in what quadrant there? Theta is in quadrant what? 4. Moreover, theta is really what? Negative. Okay, you guys okay with that? Theta is negative, so maybe you want to actually indicate that information. If you don't know, we go to the reference angle, and then that's over 1. So all of that information we did prior applies. Theta, 1, 1, square root of 2, and that's the reference angle. So you go, oh yeah, my reference angle is pi over 4, okay? Because it's the quadrant 1 angle. So if you know your reference angle is pi over 4, then what does this all really mean? Okay? Final answer. What's theta? Negative pi over what? 4. There you go. Okay, you guys okay with that one? What about something like this? Inverse tangent of 0. Go, oh, Mr. Judge, theta is tangent of 0, right? Sorry, inverse tangent of 0. That means by definition, tangent theta is what? 0, is that right? So what does theta have to be here? You guys know? Well, I'm going to go back to the tangent curve. Okay, tangent curve is right here. Oops, wrong color. 0, 0. So this first angle is theta, and this is tangent theta. So if you're saying tangent theta is 0, that happens when theta is what? 0, because that's the point 0, 0. So even going back to some of these curves and thinking about it, this is why you guys graphed it, right? This is why you spend that time graphing it, looking at intercepts, looking at asymptotes, you know, because this information is used. All right, ladies and gentlemen, and then they say, let's give you guys this calculator question, right? See if you can use the calculator. Inverse tangent of 28.6. Okay? Calculator question. Look at the process, how it's the same. Theta is what? Inverse tangent of 28.6, right? Theta, this is an angle, so we know. And even if you said, can I think of it this way? Yeah, tangent theta is what? 28.6. What does that mean about theta? Theta is in quadrant 1 because, yes, this is positive, right? So if I go to the TI now and I say, I want to try to talk to the TI and say, second inverse tangent now, 28.6, let's close that. What do you end up getting? Let's go to the nearest whole number. Okay, what is theta? It's like, is it 28 degrees? I got to go back to the calculator. I didn't even look at the answer. No, 88 degrees, not 28. Wow. And that's a degree answer. Can you give a degree answer? Yes, your calculator's set to degrees. That's fine. You don't have to give that radian here in this sense, but you can convert it if you want, either by changing your mode or by converting. Okay, if it's important to get a radian measure, but they just want to make sure you know how to use your calculators. Okay. Yeah. There's a lot more I can do, but I want to talk about this. I want to change the subject to talk about, this idea. The height of a balloon. And maybe we'll just draw a picture here, right? You have the ground here. And we should have a straight line here. And then here's your balloon, okay? And maybe I'll draw a circle for a balloon. And so what they're going to do now is this. They're going to say to you, they're going to give you something like this. They're going to say, okay, this measures 700 feet, okay? Here's an angle, theta, and then you're going to have the height of the balloon. So this is going to be a perpendicular line, okay? This is H. I'll move my balloon over. So they're going to say a 700-foot anchor a 700-foot rope anchors a balloon. And this is as shown. Find the angle theta if the balloon is... they're going to say, here's the question. What is the angle of elevation when the balloon is 400 feet above the what? Ground. Okay? Bless you, bless you, bless you. Okay, so let's read this. They're saying this is where you're anchoring. This is where the anchor is. Okay. And then they're saying that 700-foot rope. So I don't know. This is the rope. Okay. Now, what are they asking? What is the angle of elevation? A lot of times you'll even put the letter, so we'll put it to theta. There's theta. When the balloon is what? 400 feet above the ground. So this portion is what? 400. Okay? Now you might say, Mr. Judge, what do I do? Well, use the what were you given? Opposite over hypotenuse. Is that true? So by definition, sine theta equals the opposite side of 400 feet, the hypotenuse of what? 700. What does that mean? That means theta is what? Inverse sine of 400 over what? 700. Okay, now you could use that. The mathematician in me says, Daniel, simplify, that's 4/7. Okay, you guys okay with this? And then now I can do what? I could go to my calculator and say, calculator, what in the world is what? Inverse sine of 4 divided by 7. Do you guys know what I mean? And what do they say now? What is this to the nearest degree? Theta is about 35 because my calculator is set to degrees. So theta is 35 degrees, ladies and gentlemen. Okay, this is how we use the inverse sine information to find out that this angle must be what? 35 degrees. And I guess I colored it purple, so let's color it purple. Okay, so it has to be a 35-degree angle. Easy breezy, lemon squeezy. So, you know, they ask that kind of question, and then they say, sometimes they're just going to say this. Let's note. They'll say, express theta as a function of the height h. Okay, express theta as a function of the height. So you go, what? What are they talking about? Okay, let me copy that. Forgot to copy it. Am I out? I'm out for a few seconds here. So, you know what that is? That's kind of like the first question. Just do this really quick. Okay. So really, this question is just what? It's the same process, which you know is sine theta equals opposite over what? Hypotenuse. Okay? Same question, but now solve for h. Or not solve for h, I apologize. Solve for theta. You're used to solving for h, but what do they say? Express what? Theta as a function of height, that's h. So in other words, they're saying write theta equal a function of height, f of h. Okay, that's the language. Theta is a function of height. So you say, oh, I know what I can do. This is by definition what? The inverse sine of what? H over 700 here. Okay? So now you're free, and you say, what good is this, right? So why do we care? Here's the answer. Okay? You can use any h. You can now use any height. So if I say, oh, if the balloon is 1,000 meters, you guys see what I'm saying? Or feet, whatever. If it's 2,000, what's the angle type of thing? That's really what they're asking for here. So this is kind of a common question, a common application here of inverse functions. Finding the angle. Anyway, I'm going to give you guys a quick example here. Evaluate the following. Okay. Give you guys a few minutes to try this out. Let's see what you get, and I will be right back. All right. Okay. So maybe we have time for one. Don't know, but let's see how to do these. You guys know how to do this? What is sine, by the way, of pi over 3? Is that, what is it, sine of 60 degrees? So you're going to say this is the square root of, so you're going to replace this whole thing now. The square root of 3 over 2. So what they're really giving you now is the inverse tangent of 2 times what? Square root of 3 over 2, or inverse tangent of the square root of 3. Is that right? Okay, maybe you want to see all of that. And then you might be very happy about this one. You say, why are you happy? Well, you say, okay, let theta be what? Inverse tangent square root of 3. By definition, tangent theta is the square root of 3. But I think we started the day with this. That might have been our first example for inverse tangent. Is that true? So you go, oh, I already know that one. We already did that. You say, where did I do it? Inverse tangent. Where is it at? Where is it at? Where is it at? Over here. Right here. Pi over 3 is the answer. So we got that one, pi over 3. Excuse me. So that goes here. More importantly, that goes right where? Here. Okay? All right. What about the other one? What's cosine of 30 degrees? Is that 1/2? So you go, oh, they're really asking me for cosine square root of 3 over 2. I don't think we did this one. Right? So the process will be, let theta be inverse cosine square root of 3 over 2. Right? And then by definition, that means cosine theta equals what? Square root of 3 over 2. Now, I know that this answer is what again? This is what? Positive. What does that mean about theta? Theta is in quadrant what? 1. So, adjacent over hypotenuse. What does that mean this is? 1. And then you go, oh, I know. This is going to be now what again? This is 1, this is 2. Oh, theta is half of what? Theta is half of 60. Right? Half of 60 is what? 30. I got to charge this really quick. Oh, come on. Okay, theta is half of 60, which is 30. And that's what that's going to be. Theta is pi over what? 6. So final answer here is going to be pi over 6, ladies and gentlemen. So let's copy pi over 6. We could just put it right here. Equals pi over 6. Okay? All right. So let me say this to you guys here, okay? I inputted in Canvas your homework on this section. It's under assignment number what now again?